Hello everyone and welcome to the workshop for RapidMiner Studio R and Python. My name is Kostas Bonikos. I'm a solution architect for RapidMiner and I'm based in London. And I'll be taking you through the exercises today. So I assume everyone has everything functional and you've got the data that I've sent to you. So we're going to create a repository. I already have a repository here and I have a folder in it where I have my customer data. You can put this GeoIP DAT file in where your repository is and it will show here. It's not necessary. This is a bit of a trick I've done here. You can just leave it in your C drives. So leave it somewhere where you can point to it. So I would say just the C or your home directory if you're on Linux. And then you'll see in the code how we get to that. So as long as you have something called workshop Python and R set up, either a folder or a repository, we can get started. And what we first have to do is I've sent you this customer data and we'll have to create this data source. So what I've got is a let me see, data creation somewhere. Yeah, there we go. So no, that's different. So basically what you have to do is just get a read CSV operator from here, from the operators. It's easier, we don't need to create the data source, or we could do that now. So before we do anything else, let's just take this one and point it to your file, wherever that is, and then take a store operator and store it. That way it'll be a lot easier. Store it where you would your folder or your repository as customer data. So make sure it's called customer data as it is named here. I'm not going to save this. I'm just, you can work with the CSV as well, but it's going to be easier in the long run. So I'm just going to move on and open the data source here. So the assumption is that you're all familiar with RapidMiner enough to get to this point. But if anyone's a bit stuck, can you give me a shout through chat now so we can get to the data before we move any further? Okay, so everyone is on the same page here. Cool. Now let's have a look at our data. The use case here is irrelevant. We're not trying to solve a business problem necessarily. What we're trying to do is build a very simple classification model, but make sure that we use R and Python to perform certain steps and show the integration and show you a few tricks on how to integrate these with RapidMiner. So you'll have a lot of work that you've done already in these coding languages, and by the end of this session you will know a few ways of installing them and putting them inside processes in RapidMiner. So the use case is someone going to become a future customer? We know that because we knew about these people and they became customers. This is historical data. We have the age, the gender, how they paid, and we also have a customer ID. This is from our website, and we have their IP, which is logged, and how many pages they visited, and if they were part of the campaign that we sent out earlier, and things like that. And what we want to find is, the first thing we want to find is the country of origin. So where does this IP come from? So we want to enrich the data. And the reason for that is so that I can show you how to do this in R. So we'll start with R, which is my favorite. And let's drag and drop this customer data set here from our repository and have a look at it. This is the same data that I double-clicked earlier. Good. So you will have this, and now we'll need an execute R operator. And now it's where the trouble will start if there's anything wrong with your installation. So let's go and find the execute R operator and drag it into here. And now what I've got is we're going to use a library that it's freely available in one version. So you will have installed the rgeolocate and HTTR libraries in your R installations. The instructions I sent out were pretty clear on that, but if anyone's got any problems with that, please let me know now. Okay, all quiet. Good. So let's go and open this operator up. It doesn't have many options here. It's basically a script. So what we have to do here is we work with data frames in R and Python generally, and what we have to do is follow the data frame set by RapidMiner. So what we have here is R main equals function data. So it's a function of data. Let's see what the function does. Says hello world. Fine, but we don't need all this, so I'm just going to select all of that and delete it. And what we're going to do now is we're going to use the rgeolocate library to create a country column. So I'm afraid we're going to have to type here. So library rgeolocate. Please do let me know if I'm typing something wrong up. It's I'm trying to do a couple of things at the same time. Then what we're going to do is you will probably have familiarized yourselves with that library a little bit, but I'm just going to use some standard arguments, and I'm going to put all of these what comes out here into a variable. So I'm going to call that file, and I'm going to put in it a system file data, and now we need to actually mention the database, and that's part of the argument, so no need to worry about it for now. You can read the library documentation, but it's called GoLite2 country mmdb. There's a lot more detail in this library normally, but it's paid for, so the free version just gives you the country. And so we need to tell that database where we're coming from. And then what we need to do is basically take this file variable and paste it on the end of our data set. So what we're doing here is we're getting the country out of our database, and we're going to put it in our data. So how do we do this? It's the same way you would do it in R when you're appending to a data set. So in our case, the data frame we have is called data. So we're going to say data dollar country. So we're calling the new attribute country, and in this we're going to put Again, this is something you don't have to know about right now, but it will work. You can read details later. So we use the maxmind data and IP file. Country name. Okay, bear with me for a moment. I'm going to pause my screen share and make sure we don't get interrupted. Okay, I'm sorry, I cannot help right now with people who can't connect because I am actually doing the workshop. So if the link to the workshop doesn't work, it's not something I can do very much about right now. So let's continue with our coding here. So what these definitions are, it's pretty simple. You can read them in the library documentation. And if you know R and you know your libraries, you can write all sorts of complicated things here. This is one of the simplest things I could find to do. So what we have here from the original data set, we've added this country attribute, which is taken from this database, basically, with giving the IP and the details here. So we don't need data 2. We just bring data in, data out. So whatever happens in here is R, essentially, well, including that. But the main thing is to be able to return the same data frame. Pretty simple so far. So let's see if this will work. Let's run it and see what we get out of it. Okay, there might be a problem here with my network connectivity, which I did not foresee, or I have a typo. So let's have a look again. Library rgeolocate. File, system file, xdata, geo. Light 2, country, mmdb, package equals rgeolocate. It seems correct, so let me try something on my other system which is not connected. There might be a port conflict, like when I'm trying to connect to the marketplace. Okay. Is everyone else having problems with this like I am, or is it just me and yours is running fine? Okay, just in case I've actually mistyped something, I'm just going to take my original, if you just bear with me. So I'm just going to take these two operators from here and start a new process and put them in here, just to make sure there is no errors whatsoever. Okay, that's a small problem. I see, I must have mistyped something. Okay, so let's have a look at the code, see what I got wrong. Oh yes, I forgot this bit, but since this is already installed, I don't see a reason for this to be necessary here. But if you wish, you can copy all of this into your code. I'm still struggling to see where I got this wrong, but I think it was this this line of code that was necessary. Okay, so what we have in our results is the country. So we brought the country in. Well done. That was easy. What we're now going to do is we're going to go back to RapidMiner and continue working with these things. Of course I can. Let me just paste this, copy and paste this, so that everyone can grab it. I'm even going to take the comments. Bear with me, chat. Okay. So I'm just going to wait and see. This is one thing I did not foresee, that there's going to be typos and people are going to make mistakes that, like I did, because of the code. So for now, we've enriched our data a little bit. Fine. What I want to do now is I want to continue working on the data, and we're going to do some stuff that we know already, such as some further data prep. So to see that everything works from here, we are going to remove duplicates. So in order to remove duplicates, we use the correct operator, remove duplicates. And then what we're going to do is we're going to say, okay, I want you to do this on a single value. And that one has to be the customer ID, so no double customer IDs here. And I want you to include special attributes, even though we don't have any, I think, yet. Let me see the results. Oh, we do. Okay, just in case. So from 1,000 examples, let's see what we get now. Again, everything is running in R, so this is going out into the R installation and then coming back. And we have a few duplicates, so a few customer IDs appear twice. So we have 978 examples now. What else might we want to do to the data? We definitely want to set a a label. Sorry, I got a bit stuck there. We want to set a label, and we might want to drop some data. So let's take a select operator and select attributes and put it here. And let's say I want a subset just to have a bit more control here, and make sure to take invert selection because we're going to drop a couple of things or one thing just to. So the IP is not necessary, so we're going to drop that. And so what else have we got? Age, country, future customer, gender. That should be fine. So let's click OK. We can see what we've done with the data so far. And now we will have no IP address, which is not necessary. Now we have where they come from and their customer ID. And so now what what I would do in RapidMiner is I would build, let's say, a predictive model. So let's build a cross-validation with a decision tree, and very simply build the model on this and test it. So let's find the cross-validation. So the cross-validation, what it does, in case you're not too sure, it takes the data set, it divides it into a number of non-overlapping subsets. So I'm going to take the cross-validation and place it here. And that number of subsets is then used to, on one side, train the data. So we use 9 out of 10 in this case to train the model with the data. And then we keep one subset out for testing. Then we put that one back in and take a different one out. And we train on 9, test on 1. We do this 10 times. And we've effectively used all of our data, both for training and testing. So this number is 10. I'll leave it at 10. It doesn't matter if it's 8. If it's 1, obviously, you're not cross-validating. If it's 2, you're doing split validation. If it's anything more, you're cross-validating. And it's a very good measure of performance. It's closer to the truth. So what we're going to do now is we're going to build this model, open it up, and build a decision tree. So let's find the decision tree and grab and drop it here. We're going to go with defaults. This isn't about performance so much, it's about functionality. Then we're going to need an apply model operator. Those of you who have recommended operators, it will be the first one down here. So I'm going to grab that one and connect the test set to this. You should all have had some experience with this. It's not very complicated, but if you find any issues or if you're stuck somewhere, do let me know and I'll do my best to help you. So we're using a very simple performance measure. Did we get it right? Did we not? How many we got right? How many we got wrong? We're passing the test data, typical plumbing for a cross-validation. And so what we're doing here is we're building a decision tree. We're validating it to find what performance it gives us. So I want the model and I want the performance as well. And I'm going to run this. And so far we've done very little R. But R adds the country to our data. And then we can build a predictive model that is this one and it is this good. And this is what we're interested in at the moment. So what if I wanted to actually build a model using R? Let's say last night I got this wonderful new library that a colleague of mine completed in a university, and they sent it over and they said, we can do better. We can do the decision trees that are better than your RapidMiner. Can you try this package? So can I try the same thing by building a cross-validation? Yes. So if you follow me with this, I will do another cross-validation. So let's take this cross-validation and copy it and paste it here. And now we're going to do the same thing with R. So inside, we're going to replicate what we did. So let's connect this one and choose yes this time and use a multiply operator. And then we're going to take also the model and the performance from here and output it. But so far, we're only using RapidMiner. So I'm going to go into this cross-validation and rename it first of all. Cross-validation R, and I'll leave the other one as is. Before we move into this, I know I've been going very fast for beginners, so this is not for beginners. But in any case, I would like to take the time to make sure that everyone is on board and on the same page. Please use chat. There's not that many of you today, so sometimes low attendance is a good thing. I expected about 50 people. I got quite a few less. So you can treat this as a tutorial, as a small group, And please ask questions or let me know if you're stuck so I can help you out. Okay, don't be shy because some people are going to be shyer and they will have the same question. But if you are going to be shy, I am going to send you all of our work and the recording of the session at the end of the session. Just please don't do interrupt me and tell me if you can't hear me clearly or if my screen is frozen or something like this. So let's go and do this cross-validation with R. I talk too much. Okay, double click on this, and now we're going to use R. So earlier we used execute R. We're going to use execute R again. So we're not going to use a decision tree. Let's delete that. The thing we're going to do now is we're going to find an execute R operator again. So let's grab that and put it here. You'll notice that every time we connect the port, we get an option for another one as well in these. And there's a little bit more to this one. Actually, there's a lot less to this one in terms of writing code. But I'm going to copy and paste it if it doesn't work for you. But first, let's try to type everything, and then if it doesn't work, we'll do this again. What I'm going to use is I'm going to use a library called RPart. So it builds a decision tree. And what we need to do is let me just go back to design for a bit. The future customer is our label. So we need to set it, yep. And so let's open this. Let's delete everything from here on and start our code. So we're going to set the label. We're going to set the method and what the data is. The data is called data, quite conveniently here. So we leave everything else as is, but we have to use this library called RPart, which I think I asked you to install before our session today. If I didn't, I apologize. Please go and do that. And I'll wait for you if necessary. And then we're going to create a model. And in this model, I'm going to place the output of RPart. Let me see, is anyone on chat? Nope. RPart, and then let's put our target variable, future.customer, and then just follow me with this. I'm struggling to find this on my keyboard. That means the rest of the data is inputs, and then we just put this little squiggly line dot comma, if you can't see the screen very clearly. So we put future.customer just as in our data set, and this is our label. And then we put the squiggly line dot and comma, and we set the method to be class. So class and data equals data. So what we've done here is we've named our label and everything else. So after the squiggly line, everything else is inputs. So everything else is a regular attribute in RapidMiner speak. So this dot is like a star. It means everything. I'm going to send you some more comment on there's going to be comments on my original stuff that I'll send you out. But this should work, except for the fact that we want to be returning first the model, So as you can see, what we have down here in what we're returning a list of outputs. And what we want to be returning is the first port and the second port. So everything is in sequence. So first is the model, and then we return the data that we got in again. So the original data, the example set. So this time we have two outputs, and when I click apply to this, yeah, everything seems correct. We should have a model come out of this. Now you'll be getting a lot of warnings left, right, and center about everything being wrong. You know, the universe is ending. That's because we don't have metadata. It's not a problem. If you don't run the code, nothing is in there. RapidMiner gets suspicious and warns us. It's fine. The yellow triangles here are not a problem. So what we're going to do now is we're going to apply this model to the unlabeled data, but we're not going to use the apply model operator. We're going to use R again. So let's grab another execute R operator and put it here. And what we want to do is don't connect it automatically. Connect the model to the first input and the test set to the second input. So now we have to make sure that we get the model in from model. And let's go and modify that code. So what's happening here is this is executed, this code here is executed by R. So in your R installation, there's going to be a model and there's going to be data in RapidMiner. So what we're going to do is we're going to take that model. So we're talking to R again. So this is like a window to R. It's not RapidMiner doing these things. So let's again delete all of these and add some code here to apply the model. So we want a result. So let's type result here and put in it the predict of model applied to data. So pretty simple. How do we know? How is this kept? It's kept in R. So we create a little artifact here called result, and we want to add that to our data, obviously. So we want to go to data and dollar the prediction. Actually, let's make it capital. And in the prediction, we'll put the result. We could have just put the result there. If we ever want to do anything else in there, we will have to, we can now, it's a bit more flexible. So let's delete everything else and return data. So what we're doing here is we're taking the model, which is in the R engine's memory. We apply it to our data, which is the test data, and this is handled by the cross-validation operator. Then we take this output and we append it to our data set under the name prediction, and we return the data. So let's click apply, and then we have a performance operator. Do we need to go to R for performance? Not necessarily. So we can we can just use performance from RapidMiner. And now is the moment of truth. This ideally should work unless I've done something wrong. So before we do anything like this though, go to your workshop. So if you have a workshop folder like this, where I have my previous work here, go and right click and store the process and give it a name. I'm not going to save this one because I have my original. I'm just going to do this. And these are self-contained processes. So from start to finish, all the work in R is going to be in one process and all the work in Python in another. So let's run this and see if it runs or not. Fingers crossed. That's always the case with code. The R script failed. Okay, let's see, what did I do wrong? So let's do some troubleshooting here. Let me check my original as well, just in case. So we have, let's delete these comments, confusing. So we have rm main function data. Oh, we need the model, of course. Someone should have picked this up and tutted at me and say, you're supposed to be teaching us this and you forget to bring the model in. So let's do this again. Right, first of all, we bring the geo data in from the IP, and then it's running now, or not. Okay, now I know why this is happening. So you might get an error like this, and you should, because we've left the customer ID in, and it's taken as an input. So since the label is set in there, we don't need the customer ID. So also, I have a strong suspicion that the RPart library really doesn't like non-numerical inputs, but so we might have to use a nominal to numerical. But for now, let's go to select attributes and remove the customer ID as well. And let's run it again. In my original work, I did convert everything to numerical before it goes into R. Exactly. And I am causing these problems on purpose. So we need a nominal to numerical to recode nominal variables because the library doesn't like them so much. So let's find one. So you'll have to go back and forth. Even though your R is fine, you'll find that you'll need to do your data prep in RapidMiner to accommodate. So you need to have a good understanding of your libraries. So let's go to nominal to numerical, that one, and place it there. No, we place it here. So we convert all the nominals to numericals first, and the way we're doing this is, let me just make sure I'm doing the right thing here. Bear with me. Yep, dummy coding is fine. All, yep, that should work now. It's quite easy. If we had done this with code, it would be a lot. It would take a lot more care and attention. Okay. Doesn't have a predicted label attribute. Now that's a bit strange. So let me change this performance metric and get performance for classification, just to make sure I have the right one. And put that here and the performance out and run it again. And now we will see that again it shouldn't work because we need a post prep step here. I know these things must look a little bit tedious, but it's good to keep the housekeeping under control, and then once you've done them once, you can do them again and again. So let's do a few things here that I didn't forget to do, but I've been leaving them. Before we do all that, though, can I just check that everyone's okay so far? If someone isn't, actually, please let me know. So I know we had a late joiner. Don't worry about it too much. We're going to be sending everything out later. Okay. So we need to set the role. We need to make sure that our prediction conforms with yes and no. We need to do a number of things here. So, and we also need to make sure that the prediction is binomial and that these things are remapped properly. So what we're going to do is follow a few more steps, and then we're going to bundle these for future work so you could reuse those most likely. So first we need to tell the computer, because the prediction now is numerical, whether it's a yes or no. The main complaint we have, if you look at it, is I'm trying to get the same error again so I can show you that the label is the wrong type or something like that. Yeah. There is no predicted label attribute, so we need to set the role, but we also need to have a something that can be classified as yes or no. So just follow me with this, and I hope the logic will become apparent. If not, I will try to explain this as we go along. So let's get a generate attributes operator and place it here. And then we're going to create a prediction attribute. So we'll call it prediction. And we're going to say that if this prediction is less than 50%, then it's a yes. And if it's more than 0.5, it's a no. Okay. Variables weights differ. Okay, let's go and have a look for execute R2. So in here, this one, okay, I don't know why this would be happening. Is your encoding the same as mine? So for numerical, nominal to numerical? So it's all dummy coding, all zero and warning, okay. And then you go in here and you get the error here. Let's look at the code and let's delete any comments so they're not confusing for now. I'm not sure why you would get variables weights. I've never seen this error before. But we're coming to the end of this, so if this isn't, if there isn't something obviously wrong with your code or your connectivity, how you've arranged things, let me just have a look. Okay, so it was in the code. No problem. No problem at all. Cool. It's good that we're on the same page and we can continue. So The performance needs to look at the data and compare and say, is it a yes or a no, like in the original data. However, what comes out of here is numerical, things will not work. It's important, just like we recoded here to numerical, to build the classification, apply it, but then before we measure the performance, we need to go back into a discrete world. So we're going to generate attributes and build an if statement for a prediction. So let's create this variable called prediction and give it a value, an if statement. If the prediction is smaller than 0.5, then it's a yes. Otherwise, it's a no. Okay. So let's click OK. And then we're going to set this as our target variable, as our label. So we need a set role operator. I'm just going to take this down here to make some more room and make sure that the prediction, which doesn't appear because we haven't encoded it yet, is a prediction. So prediction that we named is a prediction. I take it up to now you've been using RapidMiner with regular attributes, IDs and labels, and you've been wondering where the prediction comes in. And this is one of the cases it becomes relevant. So everything else is irregular for now. So now we're going to make this prediction a binomial. So we're going to create a nominal to binomial. We are being very strict here about our typing. I think it would work as is, but I can't remember what sort of problems I had that I fixed this. But let's do this properly, very strictly, and make it binomial explicitly. So we get a nominal to binomial, and then we pick a single one, the prediction, and it doesn't exist, so we have to type it in. And make sure to include special attributes because prediction is a special attribute and it will be blind to it if we don't designate it. And finally, we are going to take a few things here. We're going to remap the binomials that we created. So we're going to use a subset and this is not going to be very easy. Bear with me. Okay, right. So how do we do this without the metadata? Subset, we can't just select attributes here. Okay, let's leave this out for the moment and try to run this, and then I could probably take advantage of the metadata, unless it just chooses to work as is, in which case we won't go that far. Okay, I must have done something wrong with the evaluation here. So it's prediction. If prediction is less than that, then yes, otherwise no. Okay. Let me just double check the grammar in this. It is correct. So if you're not sure if you've made a typo in an expression, it's good to open the calculator button and see if your expression is syntactically correct. And just bear with me for a moment. I'm just going to try something on my other system to make sure I have everything in the right place. You are right. I think yeah. Or I could just change that to a lowercase b and that should fix everything. There we go. Thank you very much. So there's an experienced coder. Let's run this now and it should work. That was a rookie mistake. I should not have done that. Okay, and there we go. So let me just try and go back and make sure I can whether I can remap these to make sure everything is properly done 100%. This is not necessary. I'm just going to delete it for now. The output of this in the results, which have disappeared, so we have to wait a few seconds, is embarrassingly good. So it takes a lot longer to do this in R, understandably, but the performance is a little bit better than in RapidMiner, very little. So it's 99.69. Oh, is it the same? Let's see if I can see the differences. Right, so let's go inside here in the cross-validation and rename the performance as performance RM. And then we go to the other cross-validation so we can tell them apart. And I don't know what I just did here. There we go, fixed. And go to this performance and rename it as performance R. So when I run this again, ideally I should be able to tell them apart. Okay, so performance R is 99.69. Performance vector from RapidMiner is the same overall, but we seem to have a difference in the class recall for yeses. So if I was in a business context, I would be tempted to pick R because it might misclassify yeses, but actually no, I would pick RapidMiner because it's less likely to misclassify no's. So if it's a future customer and it's a yes, it will identify them better. That's the variable of highest interest, the yes, the class of highest interest. So after all this work, we are able to do this correctly. So the lesson here is if you can do it in RapidMiner, do it in RapidMiner. It's a lot faster, a lot more elegant, simpler. You get your options in front of you. However, if RapidMiner doesn't do it, and 99% out of 100, it will be able to do it. Okay, it doesn't do this geolocate, so this is great to use R for, but as you can see, you can even cross-validate, and you have to do some engineering around this, but it's one of those things. If you have to use R, again, this is because of this particular R-part library. I wanted to use one that's easy to get for everyone. It doesn't have too many arguments. If you use another library which is more forgiving towards nominal variables, you wouldn't have a problem at all. So let's save this. You save this. If it doesn't work exactly, I will be sending this out. And in order to save some time, I'm going to go a little bit faster with Python because it has a little bit more detail. Is everyone ready to move on to the Python version of the same work? Cool. Is anyone not ready? That would have been the right answer. Excellent. Everyone says they're ready. Okay, let's go to Python. So you've saved this. I'm not saving this. I'm just going to start a new process. And what we're going to do now is we're going to bring in the same data set. And then we're going to get an execute Python operator to bring the geolocation. So let's bring an execute Python. And there's a reason I asked you to all install pandas, PyGeoIP, because then we will have, and requests. So we will be using all of these today. So let's open the execute Python. Perhaps I should have sent you the scripts as well because it would save us a lot of time. I'm going to start by deleting the second data output and everything else in between. Again, the same data frame here. Let's delete all the other things. Actually, pandas is essential for using RapidMiner and Python. So we're going to import PyGeoIP now and import requests as well. And we have to be careful with Python because its indentation is everything. So let's put one tab here and say set a variable called geoIP to equal PyGeoIP dot geoIP. So what we're putting in this is wherever you've saved your file. So I've saved it in C because unfortunately I have to use Windows. In C, so it's geo IP. I can't be looking at two things together, so if you're asking me, I might have to ignore you for a bit while I'm typing this. So cgeoip.dat, you'll have to point to where you've saved this for yourselves, and then we give PyGeoIP to memory. If you're not familiar with all these arguments, I'm not familiar with all of them myself. Just follow along and then you can go and read the documentation for this, which is another reason to use RapidMiner if you can get away with it. You don't have to read documentation in order to see your options. So let's define country. And then we will actually go through our data and append the country name for each record. So there's a for statement here for row in data IP. I think I'm doing this correctly. Yeah, so we're looking at the IP for every value of the IP in data. We want to, another tab, country dot append GeoIP country name by address. So that's the argument here, and we put it to rows. Okay, this is a little bit cryptic for people not familiar with this. I certainly had to spend some time to develop this. I wasn't sure how to get everything running in the first try. So it should work for you. If you just type it in, the details of the Python code you can be more or less comfortable with, but it will work for you. I'm just showing you how to do things. So let's go to data, oops, square bracket, and put this country name by address. And call it country name from IP. From IP and add country. So basically we're adding the country to that data and we're returning the data as is. So fingers crossed, I haven't mistyped anything here, and this will work for everyone. So as you can see, we're doing the same things with R and Python. Again, oops. And like with everything else in coding, nothing works the first time. Let me just double check. Let me open my original notes. Requests, data. GeoIP dot. I can't see anything wrong, but oh, there we go. That should work. Unintended. Oh, you have to love Python. I'm not sure where the indentation is wrong here. Country name from IP, return data. If anyone has any ideas what I might be doing wrong here, give me a shout. Script line 12. Does anyone have this working? Okay, let me open my other one for a moment and just double check. I'm using 3, the latest 3. So is anyone else having the same problems with Python? So let me show you the settings, what I'm using for Python. It doesn't say here, but I know it's Python 3.5. Okay, let me open my original one just in case there's a typo. And take all of these out for now. Okay. And just run this single. Now, I really cannot imagine what I've done wrong here, but I have made a typo somewhere. Okay, let me just copy paste this out to you after I remove all the comments here. And try it again just in case. Because there was a typo somewhere, and that's the risk of doing a workshop with actual code. Anything more than a line tends to introduce these typos. So just be very careful how you space this out, because it's going to mess up your code if it's not, if everything is not arranged properly. For the life of me, I can't figure out what I typed wrong, but we need to move on. So please let me know if anyone hasn't got this working after I copy pasted your the script over to you. And let's move on, because I want to show you something really cool. So I'm not going to do a cross-validation with RapidMiner in this case. There's no point showcasing that and comparing them. I will send you one with a cross-validation from RapidMiner, but we need to keep time under control. So unless anyone has any issues and this thing is not working from this point, I'm just going to continue working. So please let me know if your code is working, if your code is not working after the first execute Python. Okay, so we need to set the role again. So let's set role. And again, we need to do certain things, but in this case, I'm going to, the conversions are a lot easier, but to save time, I'm just going to lead you through doing an optimized parameters grid application of this. Ideally, we would just do cross-validation and then wrap this around it. But if you're experienced with RapidMiner, you'll see where I'm going with this. And I'll be sending you the work and save some time as well. So again, the algorithm wants things numerical. So let's do the same, nominal to numerical. It will convert all the nominal to numerical, all the nominal variables to numeric ones. We are not going to go by defaults in this one. I'm going to choose unique integers for in this case, and make sure you include special attributes. The differences are explained here, why I didn't use dummy coding, and it will make life a little bit easier as well. So now I want you to just follow with me and let me know if you get stuck somewhere, because we're running out of time. So let's get the next time I'll do this, I will book more time actually. So let's find the optimize parameters grid operator and place it on the canvas here. And when we go inside this, just open it, and then we'll put a cross-validation in here. And connect it as normal. So we'll take the data and we'll output basically the performance only, because that's what we're interested here. And then inside the cross-validation, so now we're doing a parameter optimization in the algorithm. And how are we going to do this? We're going to use a macro. So we're going to use a set macro operator, because we're going to pick the maximal depth of the decision tree and try different values for it. So I'm going to take the set macro operator here and set a value called max depth and give it a value of 1 as a default. So I'm setting a macro that this is max depth, and then I'm going to point to that macro to use from my optimized parameters grid to try the different values. So let's get an execute Python again and build our model. Place it in here. We'll take we'll connect this and the throughput to this, and then we'll output the model here. That should be enough. So let me just double check my code here. There's quite a bit, so I'm thinking of copy pasting this, but I'm going to go fast and type it, and I'm going to send you everything in the end. So again, let's delete any. So the imports have been done. We don't need any of this. So we are going to import a very specific thing from sklearn. I hope I asked you to install that. Tree import the decision tree classifier, and then we're going to keep with this RM data and delete everything up to here. And what I'm going to do now is I'm going to build a decision tree. Only I'm going to set its parameters, and the parameters are going to be set from outside. So let's set this one as base equals data, and just follow with me here. Age. So I'm putting in the inputs from my data set. It might not work because I'm in a bit of a hurry typing this. I know campaign is misspelled, if anyone notices. I need to go and fix it. The data came from a colleague, so I have to misspell it here as well. So before we do a fit, we'll set the parameters. And actually, no, we set the parameters. This is the model. So we use the decision. As you can see, this could get horribly wrong if you try to develop it in RapidMiner. The best way to approach this is to build your code in Python first and test it, make sure it works, and then come back here, because if you don't know your arguments or if you mistype something, this is the worst place to be troubleshooting code. This is basically for deployment, not for code development. It's not a development environment. And now we come to the macro. So here we import max depth, which is our macro. And this is in RapidMiner how we use macros, which is pretty universal, I think. And then we close the parentheses here. And that should work by setting the max depth. As you can see, we're only setting one parameter of the decision tree classifier. So what we're going to do then is we're going to fit the data, and for that we need the base, i.e. the data. We need the data for the future customer to be our target, and we can close that. So now every time the CLF parameters will be different. So what do we need out of here? Do we need the data? As you remember, I only output the parameters of the optimization. So we only need this CLF variable. Hopefully this will work, but let's see. I may have mistyped something. So again, let's pick another execute Python operator and bring it here. And this one will be a lot simpler because we don't have to put the macro in here. So let's edit the text here again, and actually we don't need to do this. We go to the previous one, edit, and just take everything from here, and we'll reuse some of the code. So let's copy everything from this side and go here and say, okay, you need the same libraries, etc. So we keep the first line. The second line, we need the model and the data. This is a mistake I made earlier. So we need to make sure we bring both in. Then again, base is the same, age, gender, etc. But now we have a prediction, which is going to be outputted. So instead of this, we have to type, actually we don't need this either. So under base, we have to get the data. Lowercase, and that should be equal to the model predict on base. So basically we're using the predict argument to return the model, and we need to append now. Actually, we just need the data, but we need to set the roles. So data RM. And this is important to remember this bit because it's not really mentioned anywhere. This is maybe documented, but when you're writing code, you have to remember RM underscore metadata. And we put the prediction to be none or prediction. And we return, in this case, the data. Why we return the data? It's for performance testing. So again, we need numerical to polynomial. We need to recode it back. It's a lot easier than with R. So let's type to poly, and we'll find the numerical to polynomial, and we pass the data over, and I think we leave it as is and include special attributes so everything gets recoded properly. And then we pick a simple performance or a classification. So I'll pick performance classification to be sure and click it here. So it's slightly easier to do things with Python, but again, it depends on the library. So you could pick an awkward library in Python that would give you a lot more RapidMiner work. So let me just see if I've got everything. We should have everything now. The only thing that's left now is to say that I want which parameter I want to optimize in, and we all know it's this max depth, but let's see if we can see it. So we go to this one, all the way up to optimize parameters grid, and we pick the execute Python bear with me, where is it? Bear with me for a moment. Okay, it should be here. There it is. Okay, there's a gotcha here that I was pretty sure it was in here, but it doesn't look like it. It's the macro that you want, but when you move it forward, it's set macro.macro, just like it would be if you picked something else. So there we go. So go to set macro and make sure you pick macro. And what we're going to do now is say we have to try a few, somewhat fewer, and make sure, well, for some reason here it's selected as list. We need a grid, and so we start from 1. If we put too many of these, it's going to be a problem. So let's go 1 to 20 in 19 steps, which should cover all the integer steps. And we don't need to log performance necessarily. So let's run this. Yeah, I put a set role operator there, and I forgot to set the role of the future customer to be a label. So in set role, future customer is our label. Did I do what I needed here? Yeah, everything else should work now. So we're getting the performance. Let's get the parameter as well that gives us that performance. And I'm feeling adventurous. I'm going to even take the model out and click run. So I am not surprised something went wrong. It's a typo. It's an easy typo. It's easy when you've misspelled something that's actual language and not some obscure thing you've set up. So depth was misspelled. Max depth. Okay. Max depth. I think it takes 2 runs and define macro. Oh, I know what's happened. We can go up here. No, that should be fine. Okay. Let's troubleshoot a little bit. So our set macro operator is called max depth depth. In here we have decision tree max depth equals the macro. Let me just double check on my original. Max depth equals oh, the indentation is correct. Base data future customer. So that's our label. Let me just save this here as Python test. You don't need to be doing the same. You could save it as Python main, but I wonder if saving it will precipitate things. please check this parameter. Okay, I think I may have, oh, the macro is set here, so I don't know what the problem is here. Okay, does anyone see what I've done wrong here? I don't see anything really different. Is your code working? Okay, let's have a look at macros. Let's go to View, Show Panel, Macros. View, Show Panel, Macros. And make sure I have it defined. Oh yes, you see, feeling adventurous is a bad thing, since we don't output the model. That should work now. Nope, it still doesn't seem to get the macro. Okay, I'm going to revert. Yeah, I think the macro is not executed at the right time, but for some reason it works in my original work. So I'm just going to cut it from here and try this. Let's see if it works. Not too sure, but let's put it here. Okay, let me just double check the order to one. I thought that was the case here. Oh, I don't know how this happened, but set macro seems to have lost its value. So let me just go to and save it and run this again. Okay, let me just revert to my previous work. I don't want to spend too much time troubleshooting here. I'm going to go to Python main, and then I'm just going to go in here and see what is different. So max depth is the same, and here we might have a bit more. Not much is different, so this should not run as well. What am I returning? Yeah, this one seems to be working. Okay, this is the one you'll be getting. I spent some time building this carefully, trying to recreate this under the pressure of time is always a bad idea. So RapidMiner gives us a performance of 99.60 and Python 99.90, so it's marginally better. And there's our accuracies for the different values. The best accuracy is given by 7. The parameter is 7, that's giving us the max depth. The key thing to take away here is, first of all, typos count when you're using code in RapidMiner, so you have to be able to test your code somewhere else first of all, and when you do bring it in, you need to be careful with the different settings you need in here. Not a lot of trouble to change your code if you have code. As you can see, it's pretty much Python, and you can even use cross-validation. Of course, you could probably do that in Python, but you can do optimized parameters here. You can pass things further on to your further analytical workflow. And what will happen here is that you can also take this workflow now and create a REST API web service on server. You can actually push this down to a Hadoop cluster if you have R and Python installed in Hadoop in each node. You can do pretty much everything you can do with RapidMiner, except you have to take a little bit of care around these things, and you can even use optimized parameters grid, cross-validation. So it's not for simple things just like this. It can be part of your process. And this becomes particularly useful when you have new libraries. So this extra work, the macros and the conversions, come in handy when there is a marked benefit for using something brand new that would give you some better performance. Typically, I think the amount of time it takes to build a cross-validation with RapidMiner real estate is very, very small. So I could take 30 seconds to build this. Nothing can go wrong. So if you can, you should. If you cannot, because there's something like geo IP addresses and things, then you can use Python. Or if there's something that's so much better performing and brand new, you can always convert things back and forth as necessary and use your programming. So at this point, we are pretty close to the end of the time. We have another 20 minutes. I'd like to take questions here from people about, if you're stuck, if there's something you don't understand. Not about coding, about RapidMiner and what we're doing here. So I can't really advise on which library is best for deep learning, but I can tell you how it integrates with R and Python here. As everyone else got their code working, I couldn't really find what I did wrong here in this last one. The code seems perfect. I'm not going to be sending the XML. I'm going to be sending you the whole repository. So this and R, the whole thing, I'm going to be sending it out, including the recording for this. So while we're doing questions and answers, I think I could stop recording here, and we could take some more time to do questions and answers and keep the recording as concise as possible. So for now, don't hang up yet. Thank you for your participation in today's workshop, and we hope to see you in the future. Goodbye.